Hey everybody, thanks for joining me tonight on Houdini Hangout. It is the last day of May, and yeah, so we're here doing some Houdini. My name's Peter, if you haven't joined us before. I just recently started um, in a position with side effects doing training um, for the education team there, and got to actually go visit the office this past week, and that was a lot of fun. Got to meet a lot of really cool people that work there with me, I guess now, which is kind of crazy but exciting. And yeah, everybody there is really awesome. I can't say enough good stuff about the people that I got to meet there. So yeah, if you are a lover of Houdini and are just wondering what everybody's like behind the scenes, they're all awesome. So I don't really know. Sorry to burst your bubble if you're hoping there was some drama behind the scenes, but it's great. Everybody's really, really nice and welcoming, and it was just really a very nice time. Um, so yeah, so tonight I think we're going to be playing around with some viscous fluids. That's kind of my plan. I have a little thing that I'll show you first that I did, I guess, several years ago now. Um, so I'll have to kind of try to remember how exactly that worked. But um, but yeah, it's kind of a concept that was actually, I was kind of trying to come up with a way to. This was obviously in production, but I was trying to figure out a way to um, make a fluid turn into something hard, right? And that it's kind of a tricky process when you think of it, from that standpoint. Um, and I was really struggling for a while to figure out what to do to make a flip fluid be able to hold a really very specific hard kind of shape to it. And so I was kind of racking my brain for a while. I started doing a bunch of different tests as one often does in Houdini, and just started kind of throwing stuff out there, seeing what stuck, and wasn't getting anywhere. And um, at the time, I had an intern, really awesome intern. His name's Zach. He now works as basically, he basically has taken over the responsibilities of all the rendering and making stuff look awesome and modeling and all that kind of stuff over at D Post in Buffalo. And he he was an intern, and he had this idea. He was like, so what if instead of trying to make this fluid stop in a really specific shape, what if you let it kind of go a little bit past where you want it to be, and then basically kind of push like a mold almost around this drop basically that was forming, and like you could almost like make an impression into the fluid and boolean it out. And he was like, I know we mainly worked in cinema at the time, and this was one of probably our first big um, very heavy Houdini projects. And we were I was like, oh, that's an interesting thought. And at the time, we were pretty used to the Boolean in cinema, and if you've ever used it before, you know that it has its weak moments, which are sometimes often, and they've probably improved it over the years, but it never has been like a real solid thing that you could do in like an animated sense. For a still object or whatever, it would usually work fine, but animated would be another thing. So I was like, oh man, that kind of sounds crazy, but we can give it a shot. And so we did, and it ended up being like the absolute perfect solution. So I'll show you the spot, I guess, that we did. Um, no reason not to. Unfortunately, Zach is not credited on this, but he should be credited for that alone. But anyways, here, let's take a look at this, and I'll kind of let it play down. I don't think it's up. No, it's only 30 seconds. So this is for a golf company, Encore. The idea is that there's like multiple different types of there's like 3 different types of golf balls for them, and we tried to like come up with these different like kind of systems to kind of um, represent their different golf balls. And so there's one that's metal, there's a metal core, which actually, if you play golf, is pretty unique. And there's one that's like a polymer core, which is like their soft one. And then there was this like combo kind of like elixir new thing. And so we wanted that to be a little bit more magical and like kind of mysterious, maybe fluid or something. So that's what we went with. And so yeah, so that's what you'll see here. So let's take a look.
Elements, each with their unique character. Fire-forged steel creates unprecedented control. Chemistry delivers a touch so soft, combined to create a level of performance previously unimagined. Like magic, the elixir, the new tour ball from Encore.
Yeah, so this is the effect right here, and you can see that there's this drop that kind of goes floating up and hits this sphere, and so it starts to kind of retain the shape of this golf ball, and then slowly you can see from kind of top to bottom the dimples start to press into it, and that is actually where the Boolean, this like kind of active Boolean is happening. And so, or animated Boolean, sorry. And so basically, I just took a piece of geometry and just kind of shrink wrapped it, or kind of sucked it in. Had it start out outside of it, and then as the I wanted the dimples to start pushing in, just kind of animated down the object. And so it was a pretty simple thing to do, but yeah, I figured what we could do is like today maybe we'll have something that we do similar to this. Maybe it won't be a fluid that's a drop that's raising upwards or anything like that, and maybe we'll just do some viscous fluids instead of it being super like liquidy like this, and have it slowly start to form something. I don't know what exactly it's going to be. That's kind of the fun of doing this for me, is that I get to kind of create something on the fly. But yeah, so as usual, I always like to caveat anything like this with just saying, hey, I'm not the be all end all in Houdini. And if you have any thoughts or anything like that that you'd like to add into this conversation, I'd love to hear it. Um, if you have some suggestion on a better way to do something, or something that you have a question about, or really just about anything, I'd just be interested to hear from you guys, be able to have a little bit of a conversation back and forth. And yeah, so I guess without anything further, I guess let's jump in, and we'll start playing around with something in Houdini here. So yeah, so I think the first thing I'm going to do is create start something for our fluid sim, just so we can get it working. So all right, so I think what I'm going to do, let's just drop down the geometry node. I'm just going to call this sim source colors, and just going to do something really simple here. So let's just do a sphere, and I probably don't want it to be gigantic. This is a 1 meter sphere. 1 meter diameter, I should say. It's a half meter radius. It's probably a little on the big side. So why don't we cut that in half? And I'm just going to turn this into the polygon. I just tend to like that it has a little, I don't know, I feel like the points are a little bit more evenly distributed around it, so it can make a little bit of a nicer shape or whatnot. Cool. Let's do a transform. Move this up. Let's put this, I don't know, not too high. Maybe we'll do it like 2 meters, I guess. Yeah, that works. And then I'm just going to create a no here just so I know that this is the geo. That's kind of like an intermediate step here. And I'm going to leave it selected on this because I'm just going to use a couple shelf tools to just quickly create these colliders and sources and things like that. Just a little bit faster than doing it from scratch, and can work just fine. So let's do a DOP network here. Yeah, we'll do a DOP network. No problem. I mean, eventually you're gonna have to do a DOP network. I'm just thinking if I should do it in a geometry node or not, but we'll do it this way. And I'll just call this sim flip. All right, cool. And I'm just gonna source from this. So I'm gonna go up to my particle fluids and just say emit particle fluid here and make sure I've got my sim source selected. I'm just going to hit emit particle fluid, select a fluid object to emit into, if any, press enter to complete. Nope, we don't need any. It's just going to create its own in this DOP network. There we go. I'm going to hit L just to organize this. And you can see we've got our flip fluid object in here. We've got our source surface from sim source and a flip solver. And we don't have gravity yet, which is weird. I have gravity for my fluids. Otherwise, where's it going? So let's do gravity. Hey, hi. The other thing that happens that's kind of a little weird here is that it makes this gigantic domain, which, I mean, is sort of okay because it's gonna automatically reduce itself, but we don't really want that in this case. So let's go to volume motion. Could probably set this to 5, maybe. Let's see, 555. Yeah, great. That looks good. I am going to move this up, though. I'm going to take this. Oops. Take this. I'm going to do a copy parameter. Sometimes my right click on my computer does not work. Paste relative references. I mean, it does. It's like momentary. If I let go of it, it's not a click. It's weird. Anyways, I'm going to do that divided by 2. Like that. Great. It's cool. So let's just make sure that this is working. Oh, the other thing I'm going to do, I'm going to make closed boundaries here, just so I'll make this actual, I'll make this little area here be the actual colliding surface, basically, for it. You know, that way I don't actually even have to put a ground plane in here. I can just have it just, you know, kind of go like this, and it'll hit the ground and all that sort of stuff. So let's see, make sure we've got some fluid coming in. Sure enough, we do. It looks ridiculous because it's way too sparse. So let's change that. Let's do particle separation to be 0.5. There we go, we got a little bit better of a representation here anyways. Oh, the other thing I often will do is I will turn off this, I'll hit the little display flag here, the hidden, just because I often like to tumble around based on where I'm clicking, and I don't want where I'm clicking to be that domain and then be rotating in some crazy way around that I'm not really looking for. So anyways, let's take a look at this. We've got fluid dropping, hitting the ground, splashing up, all that kind of stuff. The normal things that you would expect from a flip fluid. The one thing that I did find out not too long ago about, I believe it's in here, so there's this nice little stick on collision. And that should be good. Let's take a look at this here. Hello, hi Zach. How you doing? Glad to have you with us on the stream tonight. Nice to see you. Going to let's see. So this is that's not even a full. Let's do it. Oh, you know what? I'm gonna. Oh, cool. Thanks. Well, thanks for stopping by. Yeah, so tonight I'm going to be making a little bit of I'm going to be playing around with some viscous fluid, and then, you know, talking about, just earlier I was talking about how you can kind of almost use like a Boolean, um, after you surface an object, to be able to kind of um, create a sort of like mold for your sim. So you could simulate it within a certain area and then push, um, in, you know, some geometry or whatever to kind of create, um, you know, a more rigid shape from your fluid. The example I was using before was actually this, which I did a while ago. I'll make it bigger just so you can see it. And um, this was for a golf ball company, and you can see that, you know, the fluid starts in, and then these dimples start to push in as it goes down. So that's kind of, I mean, I'm not going to do this exactly tonight, but kind of the idea I was going for was something that would be in that realm, kind of like fluid that needs something to kind of push it in and kind of, you know, make it um, a bit more solid. So I think I'm actually going to do something that'll be, yeah, maybe I'll even do a golf ball. I guess I don't know. I was just kind of playing around. So thank you. Yeah, it was. I did that a while ago. It's been, oh, gosh, 5 years ago. Good lord. Um, but yeah, so that's what we're going to be playing around with. So I'm just kind of getting it set up, just getting some fluid stuff going here. Um, and yeah, so um, I am just messing around with this little um, stick scale. I actually wonder if it even works with this boundary box. So let me try this here. So I was using closed boundaries, and it doesn't seem to really be doing a ton. So I'm going to do a ground just to make sure. So I'm going to drop a ground plane in here. I'm just going to hit R to flip those wires. And let's see here. See how this works. Yeah, there it is. That's interesting. So the it seems like the closed boundaries don't exactly give us the fluid effect that we're going for. Now the interesting thing here is that this actually isn't. That's weird. That little extra thing. This actually isn't viscous right now. It is purely just using the stick-on collision. And right now, I could probably turn it back to where it was. Maybe. Let's see here. Defaults. Just want to see where it would be by default. Still a little too much. I'm gonna just turn that down a little. Maybe a decent amount. Just want to give it a little bit less like free flowing. Yeah, there we go. Scrub off a little bit of that speed so it's not like, you know, not flying fast. So anyways, yeah. So there is a little fun add-on here to use a little stick-on collision. It'll kind of slow it down whenever there's a, you know, whenever it's within a certain distance of the collision field. That might actually be the reason why this didn't work. Let me just turn this off for one more second here. And closed boundaries are still on? That's weird. Alright, let me just look at this again here. Just see if that's doing it still. Nope. Back to its original. So yeah, this is the thing for me, is like, it always feels like it gets too much energy in these corners and things like that, like when you have fluid dripping down. So if we go to guides and go to collision, I don't think that there will actually be a collision field. And sure enough, there is not. And I'm sure that's why we're running into that, where we're not getting any of our sticking as it goes on. So let me unclose these boundaries. Go back, turn the ground plane back on, and we should see that a collision field is made, I'm guessing? No? That's weird. Well, regardless, it's working this way, so I'll take it. Anyways, it's very strange. Not sure why it's even working. And what we could do here instead is just do, right, this defaults one cell. Let's see how that works. Yeah, there we go. That's looking pretty good. getting a little bit less crazy boundary movements and things like that. So anyways, it's something that you can play around with and mess with, but I just kind of wanted to look at that while we were in here. It's interesting. We're actually losing some... Oh, because it's not closed boundaries. That's why. I'm not even thinking. I do want closed boundaries on still. Cool. All right, cool. So I think what I'm going to do is... just trying to think exactly what I want to do here. So I think what I'm going to do is still do that, the sphere filling situation, basically. And what I'm going to do with that is... Alright, I'm going to turn off this stick-on collision. I don't know why that isn't doing exactly what I was hoping for, but it's alright. Cool. Anyways, I'm turning that off. Because we're going to do viscous. So I'm going to select this flip fluid object, and I'm going to go up here to the shelf tool, make viscous, select flip objects to make viscous. I'll just make sure it's selected, hit enter. This gives you a little tool, like a little tip to just let you know where your viscosity is controlled from. Sounds good. What this does is does a couple things all at once. If you go into your flip object, it adds a viscosity attribute. If you go into your flip solver, it turns on viscosity and it turns on a few different things here. And that, let's see here. I believe here, does it add a... No, I guess it used to do that. They might have changed it slightly recently. Anyways, that's fine. So now we should have a viscous fluid, and we, again, can control that by this physical attribute right here. And that comes in. So let's take a look at that. I've now turned on viscosity, obviously, so this will be quite a bit more viscous in the way that you would expect it to, and kind of puddle versus spread out. And so that's cool. It's doing its thing. And I think what we're going to do is create a sphere that this will fill up. Yeah, that's looking fun. Probably not going to do this super high res just so we can have some nice quick iterations going on here. All right, so let's do a collider object, and just trying to think of the best way of doing this. Yeah, what I'm going to do is just do a geo node here, call this collider here, and let's just do another sphere. This one a little bit bigger to encapsulate everything. Yeah, let's make this 2.5 maybe. It looks like a good size. Yeah, maybe not even that big. Maybe just 3. 3 will be good. And we'll just move this down a little bit. And I'm going to do the same. No, this should be fine. I'm just going to leave it as a polygon and do about 10 just to make sure you get a nice smooth surface. And I'm just going to do some normals here just in case we need that. Kind of trying to remember if we do or not, but that'll at least give us a direction here. That'll be no. I'll just say collider. Like so. And great. So let's take this collider, and I'm just going to use the shelf tool again. Not really any reason to do anything too crazy here. And select my object, static object, and that should have put it into my dot network. Sure enough, it did. Kind of made a mess of it. I'll hit L. And we'll see where this goes. Yep, ground plane is there. Didn't like how I had that set up. Now, you don't technically need this static solver, and we'll get rid of that. So, Could do it just like this. And let's see our collision guide. I'm going to turn the display geometry off, and I'm also going to hide other objects just so we're only looking in here. There's our sphere. The problem is that this is actually going to be solid, right? So it's not going to want to emit anything into it. So I believe if we do invert sine, that should invert the direction that we're looking at here. So we'll be on the other side of it now, and that should hopefully give us a hollow center. But let's, I guess, give it a shot. Who knows? Who knows if this will always work or not, but we'll give it a shot. It's been several years for me, so please give me a moment. But sure enough, it's working. Lovely. All right, cool. And if you saw there, what we're looking at is actually the collision field in the flip solver. So if you have a flip object, you can go to guides, and you can turn your collision guides on or off. And that's what we're seeing there. So I'm just going to turn them off because we don't really need to see that. We can see here we're filling up our object here, and it's kind of going a little slow. So let's up that a little bit more because that's it's not exactly what I'd like. So let's do that. Let's see. Let's make our source a little bit bigger. So we'll take the source here, and let's do it. Let's go all the way up to 1, I guess. Should be fine. That a little bit. Seems like that was causing some weirdness in the. So we'll just maybe do 2 on that. Makes it a little bit thicker, but it's okay. I think we'll be good there. All right. So, oh, that's our problem here. Right. Forgot that that's what's going on here. So if you look closely here, might be a little hard to see on the stream. It is actually just a shell of particles, and that's fine in most cases. But I think we want to just go full solid here. That's what I'm feeling. So let's just turn that off. We don't need shell thickness. And now if we go back into our viscosity, should have nice solid particles there. Lovely. So let's see here. This should actually fill up hopefully quite a bit faster. Oh, cool. I go by Zach as a YouTube superstar. Cool. That's awesome. Zach, do you stream stuff? What is your what's your kind of your deal over there? I'm curious. I'm not familiar with your work, so my apologies if I did not know that. Be curious to hear what you do on the stream, or on your channel, I should say. Because not everybody likes to stream live. I'm just a little crazy. Cool. Okay, so this is filling up. Well, hopefully you will respond in the old chat there soon. All right, so let's look at this here. So I think what I'm going to do is I'm going to add some random movement to this, so it's not just like falling down. Cool, awesome. So you do C4D and Redshift, nice. Yeah, I really like using Redshift in Houdini as well. Their implementation is really nice. It's a clean interface in there. At dpost, where I showed you the video that I've done where I previously worked, we used Arnold in Redshift, and Arnold looks amazing, it's great. It's just the implementation in Houdini isn't my favorite. So a lot of times if I'm just in Houdini, I'll use Redshift. But I mean, now I'm more, since I'm with the part of the machine, I do push Karma maybe a little bit too now. But Karma is really nice, and XPU super fast, and maybe we'll take over the world someday. I don't know. But either way, Karma is really nice too. So, anyways, let's get some random velocities going here. And thanks for joining me. That's really cool. I'm glad to have some fellow, creators and stuff like that in the channel. And hopefully you'll learn a little something about about Houdini today. Great. So we've got this surface here. I'm going to add in some random velocities to these particles. If we turn on this velocity right here, you'll see that we add in point velocities to our particles that are being created. So I should be able to just do a, let's see here. I'm going to do an attribute adjust vector, throw that in here. It's kind of the preferred way that they've created for making adjustments to attributes in Houdini. There's an attribute adjust vector, integer, float, all that kind of stuff. There's also color, and I think there's even a dictionary one now, right? So, yeah, attribute adjust dictionary. So that's for all the fancy folks out there that like to use dictionary attributes, which are kind of neat. They're like paired attributes that you can use. Anyway, so we'll just do a vector. We got velocity here. Great. I'm going to change this to noise just to make it a little more fun. Let's see where we're going with this here. In fact, what I'm going to do is I'm going to, just so we can visualize this, I think I'm going to split this real quick. So this is kind of a weird thing to be doing, but it's all right. Hopefully this will make sense. So I'm going to do a group. I'm just going to take the surface and split it one way. So this should just be the surface, no points. And then over here should just be particles, no surface. So just help us see it maybe just a little better. I'm just going to shift click on both of these here. Alt click to drop a merge down and just right there. So that'll basically, I mean, it's kind of a silly way to do this. There's really no reason to, but just a better way to be able to visualize what's going on here. So there's a lot of values in here. Now, we don't want the range to only be positive because that means it's going to go towards this kind of quadrant here. So we'll be going toward the positive z and the positive x, which will only create noise in kind of this, and obviously the positive y. So if we played this back, it's only going to be in this kind of upwards direction here, which we don't want. So let's instead do zero-centered. That's what we would like. And amplitude, I don't know, let's do like 2 or something. I don't know. Well, we can always change that. So we got our element size here. I am going to bring the element size up, actually, because I don't really want it to be, yeah, maybe like 3 will be good. I don't want it to be like diverging too much. I want it to be staying kind of in its same thing, in the same direction. And you can see here that the particles are changing, but the noise really isn't. And that's because we just need to turn the animation on for the noise. Let's hit play, and now you can see that there's kind of this crazy noise pattern going all around here. And I can turn the pulse duration maybe up a little bit. Maybe we'll do like, no, that's too far. Let's do 2.5. So now you can see that these, the noise is moving around. And in fact, what I'm going to do is I'm going to do a time shift. Do time shift up here just to stop this from moving around. I'm just going to say hold first frame. I'm going to remove this in a second, but this will just allow you to see the noise a little bit better. So there's our kind of wiggling around noise. It's maybe 2. And basically all I did here is I just froze it at frame 1 so that we're not pulling in those random particles each time. And then that way we can visualize a little bit more. If I turn this off, you can see it's changing all these point counts and all that stuff, but it just gets a little busy. So that makes it a little easier to see what's going on here and kind of how this is wiggling around and doing its thing. Yeah, so I'm going to turn that off. Obviously, you wouldn't want static points to be created because it would create weird streaks and stuff like that. So, great. So we got our surface there. We should be able to go back into this viscous sim here. And now you can see we've got some motion here. And let's see. Let's see what's going to happen here. This should be hopefully a little more interesting to kind of see something. Yeah. Cool. Could still go a little further, I feel like. Kind of got this fun thing happening here, but let's go a little further with it. Sim source. Let's go back here. Let's tweak the element size. Do you want to play with that? Maybe we should turn this back on. Maybe we do want a little bit more randomness in there. So maybe 2. I'll just cause it to kind of break up maybe a little bit more. And shoot, let's just double it. Let's get crazy. Let's get so crazy. Great. That's good to me. All right, let's try that out. See how that goes. Oh, cool. I'm on frame 143. Let's not do that. Stop. In case you ever are doing this kind of stuff, escape. It's your friend. It'll hopefully get you out of a sticky situation if your sim is trying to solve or do whatever and you don't want it to be cooking all those frames. You can just spam the escape key. Get something heavy to place on your escape key. It's a pro tip. Yeah, so you could certainly. Zach was just saying, would you randomize the viscosity amount? And certainly you can. There's no reason that you couldn't. We could play around with it and see what it looks like. Right now I have, obviously the viscosity is pretty low. But yeah, that could be a really interesting thing. Oh, I actually left the time shift on. You can see those crazy streaks happening here. I'll play it back. You can see, I hit the time thing. So there you can see these crazy like streaks because it's not moving. I mean, it works fine, but it's just weird. It's not really what you want at all. Yeah, but that's a great question. Let me go back to the sim source and turn this off. Yeah, so what we could do there is make sure that would actually come in real quick here. Particles. Just want to make sure I'm not missing anything here. Yeah, it should all come in. Cool. And then in here, viscosity. Yeah, viscosity by attribute, and it's multiplying. So I would want to do 0 to 1 random would probably work just fine because it's a multiply on it. Oh, you know what? I want to do a slip-on collision. I don't want it to have a hard kind of stick to the boundary type thing. And this should feel a little bit better then. Should kind of roll down this. Yeah, there we go. Yeah, we've got this kind of sliding back down, which is interesting. Kind of a unique little thing. Yeah, let's try some random viscosity. Why not? Might be a little hard to see if we do it, but just give it a shot. What's going to hurt? So yeah, so if we were going to do that, I would do an attribute just float. Throw that in here, and we would do this. Let's see. It's a point attribute here. Let's do noise, because I don't want it to be random. Min and max 0 and 1, that should be good. Let's visualize this. You can use the handy dandy little thing right here to visualize it. Let's take a look at kind of what this is going to look like. So let's play around with this a little bit. So we probably would want this to animate, but fairly slowly. I'm going to turn this time shift back on, just so we can see how this is going to animate through. Too slowly. Let's do 4. Yeah, it's kind of cool. So we can kind of remap this here. So let's expand this ramp, and let's just let's do a smooth. Yeah, there we go. So maybe what we'll do is have it like this, and just kind of clamp some of these values here. Just create some high viscosity and low viscosity. Oops, low viscosity areas. So maybe that's at like 2, and that's at like, I don't know, 0.8. That'll just kind of create some more interest maybe. Yeah, cool. So we've got viscosity there, and what we could do is change the element size as well. It's kind of hard to say how this will look. Let's just try it at 1. I control middle clicked there, just if you're wondering how I reset that so quick. Yeah, let's try this, see how that works. I am also curious here. Let's just see if this should come back out. So I'm going to visualize it from this node. And already I can see we're getting our viscosity coming out, so that's kind of cool. So let's see here. Let's see. Stop selecting. Yep. And I forgot to turn off the time shift again. Oh, made something more difficult, as usual. All right, so yeah, sure enough, we've got some low viscosity stuff in the purple. So here, you know what? Why don't we do this? Why don't we crank the viscosity a little bit, just so we can see that. So let's do physical. I don't know. Do a order of magnitude. See how it goes. We could just watch it from here. This should be fine. Let's see here. So yeah, we're gonna have some real flowy stuff. There's all sorts of different stuff going on here. It looks like, and I wonder how that's gonna all flow together. Now that I'm like really thinking about it, I wonder how that's gonna. Like, let's look at it over here. And yeah, sure enough, there's our viscosity attributes. Cool. Yeah, it's gonna mix pretty quickly. Looks neat though. It's cool. So the thing that's happening here, and the reason, just for you know the sake of having the conversation, the reason that Flip can keep track of these things is because obviously it's particle based as well as volumetrically based, and it's converting in and out of volumes and back and forth the points a lot, and so there is the sense of it kind of mixing and blurring and all that kind of stuff, right? So that will happen eventually with this, but it's kind of cool to see that does actually kind of keep some interesting viscosity changes going on there. It's kind of neat. Fun rainbow effect. And obviously you could do this with color as well. So if you wanted to input color into your fluid sim and have it move around, I mean, when you surface it, you can have the colors go right into it, and that's pretty simple to do. So yeah, so let's see here. I kind of feel like if we turn the element size up, let's see what that looks like. Yeah, no problem, no problem. Yeah, if you're ever interested in like the actual like technical side of Flip, or doing fluid in general, um, if you look up some of those, like if you were to go online and Google some of that stuff, there's obviously some great explanations of how it works. Another thing to note, they did change this recently. If you go to not solver, wrong. Oh, up here. So technically, what we're doing is APIC, not Flip right now, but that's on another level. So if you're ever curious about that, these are the different ways of doing. They used to just say like kernel, and one was a splashy and one was swirly. So technically, when you change to viscous fluids, you want to do the swirly APIC and not the Flip. And what that does is basically allows it to kind of handle the viscosity better. And so they automatically change that when you turn viscosity on. That's another thing that gets changed. But, looking up APIC versus Flip, really fascinating subject. I'm not going to obviously get into it because that gets super technical and all that type of thing. But it's basically different ways of doing these particle in volume transfers and all that kind of stuff. And if you're ever following like 2-minute papers or SIGGRAPH or any of that kind of stuff, there's always somebody coming out with a new way of doing particle fluids in this new method, and they'll show APIC and they'll show Flip and they'll show all these different things. So anyways, just a random little thing. But you do want to change that if you're doing viscous fluids, and I totally forgot about that, so I'm glad I came back to that. Anyways, so we've got this source. It's really moving around here. I think this will maybe give us a little bit more interest in that. I don't know. Let's see. I just kind of made the pattern a little bigger, so we'll see how that goes. So let's go back over here and let it do its thing. So the interesting thing on this as well is if you look at if you look at this viewport and you're like, well, wait a second, um, why don't we have those attributes being shown in here, right? Well, I don't know like the 100% answer, but it has to do with the fact that DOPS is a different way of holding this data. And so when we go over here to our flip fluid object, in order to see our geometry, we have to go into the flip fluid object geometry, and then we can see our geometry spreadsheet this way. So that, you know, when you go into flip the geometry spreadsheet or go into DOPS, the geometry spreadsheet changes, and that kind of gives you a hint that, hey, this is handling this data a little bit differently. So these visualizers don't work the same. So they're not actually, you know, being put on top of this basically. But there should actually be a viscosity guide, and sure enough, there is. So you could actually turn this on and get a little grid here going on. I guess you could do smoke as well. Wow, that's a wacky way to visualize that. It's kind of weird. It's like we've got like fuming red. What do you call it? Fuming. Oh, I can't think of what it is. Some sort of nitrous oxide or some crazy thing. It's hydrochloric acid or some crazy chemical thing. You watch these chemical videos on YouTube and they'll play with these dangerous things. And you're like, what's wrong with you, man? You're crazy. Anyways, that's kind of fun to look at, but doesn't really tell me quite as much. But yeah, so there you can see a little slice of the viscosity. So if we turned off the particles there, you can see it. Great, whatever. But I don't think that's the best way of visualizing it. So I think I'm also going to turn up this velocity in here because I'd like for it to really go around a little bit more and actually even come up a little bit if possible. So I'm just going to up this and just kind of go crazy with it and just let it kind of fly around and do its thing. It's kind of more interesting that way. It's like a crazy water fountain or something. I don't know. I'm going to go up to the particle fluid so you can see those pretty colors come out. And it'll help us be able to kind of visualize it moving a little bit easier. And you can see here that these red ones that are really the more viscous fluid is sticking more. And that's part of the viscosity, contribution. The last thing that we're going to really have to figure out here in order to get this fluid to work is have it fill up the whole thing. So I'm going to let this go a little bit longer, and there should be a point at which this will stop filling up. And it's probably just about there. Let's see here. Yeah, it's close. Not quite. So you can see right here, this is the top of our emitter, right? So it's bubbling up, doing its thing. And this is never actually going to totally fill up the sphere. And the reason for that is the sourcing of this geometry. Or sourcing of these particles, excuse me. And what it basically says on the source within the DOP network is don't emit within this certain area, basically, where there's the surface. So it's probably going to level out right about there. Because you could see it was coming out at a pretty good clip for a while here, like, right? It filled up all this area, and then it kind of just doesn't really do much now. Just kind of evens out. And so let's go back to DOPS and take a look at it right here. So if we look at this source surface from SimSource, that's a mouthful. You'll see that in the particles, there is a kill inside SOP and kill inside DOP. And so if I turn this off, I'm pretty sure, don't quote me on this, but I'm pretty sure this will fill up now. In fact, you can see that there's actually a lot more fluid being sourced. And the reason for that is that it's now not stopping the fluid from being sourced inside of the surface of the fluid. And what I mean by the surface is it's actually calculating the surface constantly. So if we turned this on, it actually calculates this surface on the fly pretty much right away. And it's really kind of quick to calculate. It's not a good representation of the surface, but it's a very quick representation of the surface that it calculates. It also calculates it at half scale here based on this grid scale. And so, yeah, you can see that now this is actually like filling up pretty darn quick. It's not quite full, but it's getting there pretty fast. And so the problem, unfortunately, will be that it will start to add pressure at a certain point, but we can just cut it off before it hits like the certain limit of pressure that we want it to hit. So this will like eventually fill up the sphere. At least it should. See where we get here. Kind of looks like it's almost there. So let's see here. The only problem is we do have this, viscous fluid, so it's kind of sticking to the walls a little bit. But you can see here, the difference is that inside of this, we have this velocity that's getting kicked around still, right? And in the other version, it wasn't really doing that. It was kind of just settling down. So that's one way of doing it. There is also another way of doing it with using divergence, which is another thing that we could source into here. And so let's look at that as well, just I guess for kicks, might as well. But it looks like we're pretty much full here. It looks like that filled up. You can see that filled up by 160 almost. It's a little open at the top maybe, but let's see here. Let's see where this is at. Yeah, I mean it's just about there, but you can obviously see that particles are being sourced into this. And in fact, if we look at this, I would venture a bet that this is still cranking up in our points. I just reverse the sort on this, and so we got 13. Yeah, it's slowing down a little bit because reseeding is happening inside of there, and basically what that's doing is it's not letting, the voxels. Reseeding basically takes your voxels and looks at them and says, how many points are inside of here? Are there too few, too many? Are we having like massive amounts of divergence? Should we seed in more particles or should we remove particles because there's too many? So it will, I guess, sort of hit an equilibrium, but it'll start getting a little funky and probably try to push particles out and stuff like that. And of course, I didn't set my cache high enough, so it reset. But it almost got there. And so let's, instead of doing it this way, so we could do that, but let's try this. Let's instead try to add in, let's try to add in some, let's see, from surface. Let's try divergence. That might not work from surface. Hold on a second. Thinking. No, that will not work, actually. So, I believe what I can do is, because I think it needs to be a fog. No, actually, it might work. I'm just trying to think. So, an SDF is a little obviously different than a fog VDB, and so in order to have divergence, I feel like you need to have a fog VDB, but I'm also thinking that maybe it needs to be in like an SDF that's the sign is flipped, basically saying it's a surface but it's flipped. Regardless, I think we can do drive simulation and do nope, not that. Sorry, gonna find it here real quick. Viscous fluids, particle fluids. Did they take that out of here? There was a thing that would let you. I thought it was in drive simulation. Oh. Boy, I don't use crowds enough. I don't know if I've ever looked at this thing. Interesting. There used to be a thing that was like, there was like a sink and a pump, and pump was divergence. It's interesting. I'm surprised that they don't. No. Fascinating. I'll have to ask someone where that went. Interesting. But let's give it a shot. I guess we'll do it the way that I'm not sure if it'll work, and hey, maybe I'll learn something. All right, so we're gonna do surface to divergence, and Someone maybe? Oh, we might be able to reverse the source scale. Let's see. Let's hit. Oh, it didn't like that. No. Didn't like that. Specified field could not be found. Huh. There we go. Gotta add the divergence field. That's why. Let's see. What we can also check here is in our guides, we can look at, hey, look at that, divergence. Yeah, sure enough, it's getting sourced in there. So what we could do here is up this a little bit to like maybe 5. I don't know. That might help push this fluid out a little bit more. Create some more positive pressure kind of coming away from that source. You can actually see that there is some fluid now that's like kind of jumping off the top, it almost looks like. Just turn this divergence off so you don't have to deal with that. Yeah, so that's kind of doing something interesting. Let that fill up. And then shortly we can look at how to do that little subtraction thing. In fact, while this is simming, I'm going to look up. You know what? No, I was gonna look up how to make a golf ball, but I can make a fake golf ball pretty quickly. So it won't be perfect, but it'll do the trick. Okay, so now you can see here. It looks like there is. I think there's some velocity happening here a little bit. It's hopefully going to fill up the rest of this. Hard to say. No, doesn't look like it. All right, so let's try that again. Let's see. Maybe we need to overcome gravity. Let's try 15 and see if that gives us a better spot. Oh, yeah, it will. Thank you for giving me a heads up there. Yeah, so it makes sense the way, the reason that they do this, so they don't want to crash people's computers, obviously. But when you have more RAM, you can crank that up a little bit if you want to. So I'm gonna crank it up. And after this, let's make a fake golf ball, I guess. Let's see if this works. Not sure if it will or not, but. I'm thinking that divergence needs to have a little bit more scale to it so that it can actually overcome gravity and like push the particles away from that. We'll see. We'll see if this works or not. All right. Well, we can call this good. We can all pretend that this is full, even though it's clearly not. Yeah, it'll do the trick. It'll do. So, let's just cache this out so we have it saved. So, just as a little informational thing here, this import particle is bringing in your geometry, the surface VDB, and the velocity VDB. So if you look here, it's not the surface field and the velocity field. The velocity, and then those get changed into standard volumes. You can tell that these are just straight up Houdini volumes because of this right here, volumes. So let's play this forward a little bit, and those volumes will expand. You can see they're expanded there, and we've got, however many voxels and all that kind of stuff. It's not a very high resolution sim, so we're not going to get too much into it. And then we've got the fluid compress here, which is a way of basically turning this turning these points into packed geometries that can represent them. And so you can see here that we have 65 packed geos and 2 VDBs that it's created now. So it's now created VDBs out of that, which is a more efficient way of storing volumes, and it's created packed geometries for the points, basically. And so that's a really efficient way to do it. And then we've got this compressed cache here. So what I'm going to do is I am going to save this to disk in the background, because that is nice. And what this is gonna do is gonna load up another version of Houdini in the background here, and it's actually gonna resim this technically. Sure. I don't know why it's at. Oh, must be. Yeah. Anyways, must be just like an autosave thing. And so what this is doing is simming this in the background, right? And so it's actually running a second process of Houdini. So just be mindful of that if you're ever doing this, like that this will actually start up another Houdini in the background. So it could cause your, whatever your RAM to get quite full. But anyways, so I'll let that go, and just as a fun little experiment, this should bring that cache back in, and you can see it'll play as we go, and our scene is not locked up. Now, your mileage may vary with how responsive Houdini is from this. My computer is decently fast, and I have a decent amount of processors, or cores in it, so that works out well. But your mileage may vary. If you have just a straight up like gaming machine or something that's like 8 cores or something, you might run into some different stuff. I have a laptop that I use for work, and it certainly is much different than my desktop, so you'll find it to be whatever. But we'll call this, and this is a little helper geometry. And so let's do a sphere. What size did I make that collider sphere? Oh, in fact, I could just pull this in. That's the smarter way to do this. So I will do an object merge with the sphere. So we'll say get collider. And we'll select that guy. Oh, collider right there. Great. Okay. So now we know we've got the exact same sized geometry, right? And so some of the trickiness here, oh geez, that finished already? Fantastic. So some of the trickiness here is that when we go to surface this, and let's just go later here, something, yeah, whatever, it's at the end, it doesn't matter, it's all cached. You can tell it's cached by the little drive right there. So we've got this surface that's being created, and if we turn this back onto Ghost Other Objects and come up here, you'll see that sure enough, this sphere is kind of like half sticking in and out of it. So there's a couple things we'll probably need to do here. So first of all, we know that the final shape of this that we want it to be is going to be smaller than that. If we want it to like suck into its final shape. So if this was a more refined sim, the quality of the sphere would be better as well. So there's that to consider. There's one other thing I guess I just want to touch on real quick. Sorry, before I'm a little jumping all over the place here. If we take another object merge here, it's just little. There's these extra top point inputs here. If you take the collision objects in, so I'll say here. Just copy the other thing. I'll just do it the hard way. Why not, right? All right, so there we go. So now we have our collider object in here. So if we go to this particle fluid surface, I'm going to hide the other objects again. So now if we take that collider and go to regions and subtract collision volumes, that's weird. Oh, wait, why is it? Right. Because the collider is, yes. So oftentimes, not always, but there are times when you could do this and have it actually subtract the collision volume, but because I inverted the collision volume inside of the simulation inside Adapts, it won't let me do that. But this is a cool way to be able to like get a smooth surface from your collision geometry. You can see here it's actually pretty smooth on the inside. And this is just keeping the outside stuff. But anyways, just a little tip. Cool. Yeah. So what we're going to do here is, this is our golf ball. Let's make our golf ball first. So let's do a square and a line, because this will make some nice little, what do you call it? This is going to make different sized spheres, basically. So if we do coverage to 100 here, there's only a few points on it right now. But what we could do is if we do another sphere here, this will be what we copy. And we do our points. So sphere onto those, like that. Great. All right, so we've got our collider here and we've got those. So let's do this and bring them down. So change this. So we'll do a coverage of. Actually, I'm gonna go back to size because that will that will actually look probably better. And let's change this to polygon and do them as like, I don't know, 6 or something. That cool. We're getting somewhere. Just kind of push this a little further, maybe 3.5. And I'm just going to change this a little bit. So we'll do. Oh, don't go to 0. That's not going to be happy. Yep. The joy of sliding a slider in Houdini by accident. And let's just enjoy this nice bright screen that I made. Oh man. You know, sometimes it just happens. Here goes my RAM usage through the ceiling. Oh boy, let's see if we can escape this. I was just flowing too much, trying too hard. It's time for a drink. Water, not alcohol. But if I was in production, this would be a good time for alcohol. Funny thing to say, I do not actually drink. It's one of the. Yeah, for sure. We can definitely look at that while H-Town does its magic. Oh man. Hey, I mean, at least I'm not dropping any frames, but yeah, I could definitely show how to transfer the color. It's actually pretty simple. In fact, I could probably do it with what we have right now, honestly. Yeah, we could definitely do that. And the cool thing is it would obviously move through the geometry as well. So you're doing something. It's either getting ready to crash or it's something. Can you give me that RAM back, guys? It's so close. You can't see the little pie. I got a little pie chart on my taskbar of showing me how much RAM I have. And it's like the tiniest sliver of free RAM. Oh, got bigger. It's a good sign. We should be saved, so that's my hope regardless. That will be fine either way, but we'll see. We will see. You know, the real problem with having like a Threadripper CPU is it turns your room into a sauna. This room is so hot that I can't even tell you how hot it is right now. It's infinite. Infinity degrees. Okay, come on. Give me that RAM back. Give it back. I can see it coming. Well, 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 well. Only Houdini was just a little bit more locked down so you couldn't accidentally set your minimum radius to 0. Just a little bit. You know, the problem here is that inevitably I'm going to want to go to cancel this, and the second I let go of this escape key, it's going to like come back and be like, hey, I'm working again, and then be like, nope, I'm trying to make zero radius spheres again, or a million, an infinite number of them. Oh, guys, it's going great. I can see so much free RAM right now. It's gonna happen. It's gonna happen, guys. I know it. So yeah, so the yeah, I can totally agree with that. That it's better than C4D, where yeah, it just says you're done. You're done now. The thing I do like about cinema, though, I'll to be fair, is I do like it that it can give you like the crash file. It does it in Houdini as well, but it'll often give you a crash file, which is nice. But yeah, it yeah, C4D is definitely like it just it just won't. And it'll freak out at times where you're like, wait, what did I even do? That this shouldn't have freaked out. Whereas in this case, I know exactly what I did. I was sliding a slider like an idiot, basically. You know, make this geometry infinite. It takes a lot of memory to do that. It's funny too because like when you work on a more limited computer, you think about those things more often. You know, like when you're like, oh, my RAM's a little close, pretty often. But like, you know, when I was at my previous studio, the computer had 256 gigs of RAM, so it was like you didn't even think about it ever. And then like you'd do something stupid like this, and all of a sudden you'd see the bar going up, and you're like, oh crap, shoot, I've made a terrible mistake. Ah, Houdini, I see you thinking. Wish I could pull up my task manager. It's just literally at 100% right now. Just thinking so hard. It's to do something. Guys, I'm close. I'm close to wanting to kill it right now. Patience is a virtue. Patience is a virtue. Well, wait. Sometimes I hear my fan like spin down. I'm like, oh, is it about to? Mm, I don't know. I think this is. I think I've hit my limit. I think I've hit my limit. The look on my face must just be the pure agony of just like I want to kill this so bad, but I also just want it to work. This fan keeps playing games with my mind. It keeps like spinning up and spinning down. It's like, oh, something? No? Yes? All right. I'm going to do it. I'm just going to kill it. We tried Houdini, but no, it won't. It won't. No, that is. There's like a way that you can force it. Oh, it killed itself. Look at that. Um, no, it will not create a. Did it? Wait a second. What's happening here? It's like it killed itself, but it didn't. Maybe. Yeah, there it is. Go away. Come on. There we go. I thought. There we go. Maybe not. That ran, please. Go on details now. It's... It's bizarre. Hmm. Oh, there we go. Now it's coming back. Sorry if I froze there for a second. I don't know if it froze or if what happened. All right. Now I'm back. Now I've got my. All right. Let's load this guy back up. See if we can't. Hopefully it saved it recently. Worst case scenario, we redo a little bit of work. But I have my cache saved, so that's good. All right. Let's see. Open D. Yeah, wasn't exactly recent, but it'll have to do. Two, sure. 1 minute later. Oh, it's when I did the compressed cache. It saved it as well. Yeah, that makes sense. All right, so we got the cache. Great. All right, so let's take a look at that thing we were saying um, with transferring our attributes, right? So we should have here our viscosity attributes. Sure enough, we do. Just at one. Ah, yes. Yes, yes, yes. I think we have to tell it to bring that in as well. Yep. So one of the things here that is getting no, viscosity is getting kept. So from here, all right. So what we needed to do is to bring the viscosity through properly. I don't know why it's setting this viscosity to 1. It's kind of a little odd to me. Let me just check a little later here. It doesn't seem like we get any. Oh, are we not updating what node we're looking at here? Right. Sorry, because this is the compressed cache. That's why. There we go. So what I was looking at here is I'm looking at the compressed cache, and this is all the packed geometry, and so that's why it's not showing a proper what do you call it? Like it's not showing the attributes properly. I don't know. My brain just stopped working there for a second. Anyways, so if we go here and if we just look at the particles, this will show the viscosity here. And so we know that if we come over here and transfer the attributes from viscosity as well, we can get that transferred in there. And then if we look at viscosity attribute, it should be in there. And what this is actually doing here is adding in, what is it? It's adding in there's actually a material added to this. So if we go here and take this basic liquid off, there we go. Cool. Well, now that's a real crash. I don't know why that just happened. It's really weird. Huh. Okay. Strange. Apparently didn't like that. Let's open it again. Just pushing Houdini to its limits. It can't handle doing the viscosity as an attribute. I don't know. Just was a weird series of events. Try that again. If you haven't used this before, there's when you do have that crash recovery dialog, you can open the crash file, and it will bring up the backup and say yes, and then it will bring us right back to where we were, and it should be no problem. So why that was an issue, I don't know. But there we go. Cool. And I'm just going to save this over. It'll make this one that's recovered, and then you can save it over if it's right. So anyways, file, open crash recovery, open crash file. Anyways, so here is our, here it is with it colored with that viscosity. But let's just say instead of that, we wanted to use that viscosity attribute to drive a ramp, let's just say. What we could do is then do color node here. And what we can do is we can do a ramp from attribute. The attribute will be viscosity. And then we could do any number of colors. We could do a magma color like that. You know, something like that. So our viscosity is tied in to that, and then it will animate through. And this is a fairly low resolution mesh, so you know, keep in mind that if you're doing this on a nicer piece of geometry, it's going to actually, you know, work better. It's going to look quite a bit nicer. In fact, if we were to change, oh, where would that be? Oh, here, adaptivity. This is going to actually, if we turn this down to 0, it'll create a bit of a more regular grid here. Obviously, it's going to create more points. So if we reset this to defaults, it cuts out on like 10,000 or 5,000 points in here or whatever. But obviously, if you're saving color onto point attributes, you kind of want more points. So having it be more adaptive isn't maybe going to be the best thing for you. You could also turn the voxel scale down, right? I think. Turn this to 0. No. Thought that would do it, but doesn't seem to. Oh no, it did. It did. It's just not a huge difference. It's already so big. Yeah. It's definitely yeah, it'll definitely make it a more fine mesh here, you know, and then if you turn the adaptivity off, it should, there you go. So I don't know, we could do 0 or something like that. You can just get a little bit more detail into it. But anyways, you could do that, and then you could also do smooth, I want to say, and that you could do over CD. That'll blur it out, you know, smooth it out a little bit if you want to. There's also in here, oops, in the particle fluid surface, there's also this attribute radius here, which will give it, these attributes. It'll allow them to kind of reach further there. And I think this will also kind of blur it as well. This is actually looks like this is a better control to be able to do that anyway. So, you give it radius of 10, just kind of go to town here, and then you've got like a nice, pretty nice, blended thing going on there. And like I said, if you have a higher, higher resolution sim, it'll turn out pretty nice. So yeah, so that is works pretty well. And it's just, I don't know. Yeah, we can leave it as a magma color. I don't know. It's kind of interesting. Cool. All right, so we've got this. And thanks. Yeah, it's really pretty simple. It's all about these transfer attributes. Anytime you see that on a different, there's several different types of nodes in Houdini that have the transfer attributes on it. So like if you're packing geometry, or if you're doing anything like that, anytime you see a transfer attribute, just think that you can usually have that kind of move through this stage. It's obviously not a one-to-one thing, right? Because we're taking these points and we're putting those onto the surface, right? But it's it really isn't too bad at all. Literally just putting viscosity in there, and if you had a color attribute earlier in the whole workflow, that would just, you could bring it right through and have it just go right to your attribute transfer. You wouldn't even need this color node here. But that's just basically taking that. And in fact, any of these things, like we could do it by velocity too. You know what I mean? Like you could remap it to velocity. Oh, that's getting wild. That's interesting. I don't know why that's doing that. Oh, must be because the range is from 0 to, yeah, that's interesting. But you could do it with all different, things, whatever position, But viscosity is much nicer because we have some cool stuff there. All right, so I'm going to let this now go in the background. Let's save just in background. Let that go. Let that surface those things. And then let's do that again. Let's not crash the computer. All right, so we're going to call this Geo. I don't know. What I think we have this. Let's do a sphere. Oh, that's right. Nope. Do an object merge. My computer might be a little slow and chunky here because it is making those files in the background, but already probably had quite a few made. Yeah, look at that. We already made 30. So having this is really just so nice. And if you don't know that this is based on a top network, or PDG, you might hear that as the more, those are kind of two things: top network, PDG. But basically, these are all work items, and they're all cooking out one of these particles surface to disk, basically, and creating a bunch of BGO files, some cache files for me. So anyways, all right, let's get the collider here, yeah. And then let's do here. Scatter a line again here. And those values 3.5. So that we add the sphere in here. Get up the polygon, make it 6 points. Sorry if I'm doing this a little quick, but I just want this back to where we were. Cool. There we go. And then scatter. Interesting. That's so different. All right, I'm not going to mess too much with this. I'm just going to do maybe 0.5, make some smaller ones. Yes, exactly. So let me just drag this to 0. That's just the coverage attribute, it seems like. It's interesting because the golf ball is really bizarre on that in this sense. Huh. That's really weird. I don't understand why this is not doing what I wanted to, but whatever. I don't know. Whatever. I'm not gonna work with this. Let's just get these looking sort of golf ballish, and then we'll call it good. Let's just redo that to 1. Bring the scale down a little bit here. Oh, the coverage is too high. That's right. It's good. Sure. Looks great. And this is not going to look like a golf ball, particularly. As coming from someone that plays golf, this will not look right to me, but that's okay. All right, so let's do a Boolean. This will be the first of a couple. So we're going to want to take these here, and we're going to subtract it. So subtract A minus B, no, minus A. Take this, put this in here. And look at that golf ball. If you've ever seen a golf ball that's more beautiful, I don't. It's horrible. Oh well. It's something, guys. At me. Come at me if you want to fight about it. Anyways, so there's a golf ball. It's not great, but it's something. In fact, what I could do as well is let's see here. Does this have normals in there? Yes, it does. Yeah. Oh, I certainly could. Yeah. Yep. I could just take this out. We'll just go 2 points that are on there. Now it's Booleaning it. Should have changed my display effect. But yes, you definitely can. Stop it. Sorry. Should be good. I'm just going to put the display flag up here, and then we should be all set. It's just that these spheres are too big. But yeah, you could do that too, I guess. And that would work. That's a much better plan. Look at that. Look at that. That looks way more weirdly golf ball-y. Sort of strange, but no. That is not a noob question. See, here's the problem. Here's the problem with Houdini. It's too easy to make things complicated, and I'm great at making things ridiculously complicated. That's a much smarter way of doing it, actually. So that's a good question, and it makes a lot of sense. I'm just trying to be smart about this scatter and align tool, and it really is just not needed at all. What I can do, though, and in fact I'm going to do because it'll look a little bit nicer, is I'm going to do a VOP. I'm going to go into scary VOP world, but I think we'll be okay. I think we'll make it. So here, what we're going to do is we're just going to take in our position and our normal, and we're going to say, one of these is normal, displace along normal. And so we're going to take the P, put it into the P, take the, take the N, put it into the N, displaced P, and the displaced N, and we have our little displacement thing here, and I'm just going to promote this displacement amount, promote that parameter, and let's do this. And so now, what this is actually going to do is take these points and actually just displace them out. And it looks a little weird because it's the whole sphere that's being displaced. If I did an add node first, which I could do, just to make this a little clearer, I'm going to delete the geometry but keep the points. And you can see here that this is going to displace the points outwards by whatever amount here. Oh, did I lose my normal attribute? I may have lost my normal attribute, so that might be the problem here. Yeah, That is the issue. So I lost my my normal attribute, possibly. Just see. Yep, there's the problem. Okay, I can't do that. Never mind. When I do this add node here, it is actually deleting my normals. So that's, we're just gonna forget that. All right, so here we have this point pop, and oh, I could actually do it there. I could do the add after the fact, just so we can see it. That, great. So really all this is doing is pushing the points outwards, right? So we can just use this displacement, and we have our normals, and as they displace, it's just displacing along those normals. It's a very simple thing. It's really easy to do. You just use this, and voila. You could also use a peak, but sometimes it doesn't work perfectly if it's not set up exactly right. But actually now we could have these, okay, there's too many normals. So now it will actually move these out, and we can Boolean with those as well. Let's see here. I'm going to turn this down for the time being, just so it doesn't take quite as long. And what we can do here is, if we displace these more or less, they'll kind of get pushed in. And this is almost the opposite of what we're going to do with our fluid. So what I'm going to do is I'm going to really kind of push these, make these a little bit bigger and push them out, and that'll make shallower depressions into it. I'll just find where the middle ground is here, maybe something like that. Yeah, cool. All right, so then I can up the resolution of this a little bit. Here, oops, sorry, here. And let's do it by 4. See how that goes. Great. And I can push this maybe a little more. Just going to make sure they're out a little bit more. 1. Nope. Very, very small differences here, obviously. There we go. Great. Got a golf ball. Let's call it a day. File cache. Let's just cache this out so I don't have to do any more calculation on this. And it's really easy the way they do this now. So now you can just turn off time-dependent cache, and we're good. You can just say save it. Boom. Got it. No. Cool. So let's just save it. Great. So that looks good. Just see what the normals look like here. I run another. No, it actually looks right. Look like good normals. What I am going to do though is no, this will be fine. This will be great. All right, so let's see. So we got our golf ball here. Great. So now let's take this. I should hopefully have my fluid all sourced. Yeah, look at that. Sure do. Hooray! Crazy goopy fluid here. Yeah, cool. Nice. And then we can bring in, so I'm going to take this out. Instead of calling this render, I'm just going to put a node here and say so the only reason I'm leaving that is because that it actually has the render flag enabled on it. So if for some reason I wanted that in the future on that node, I would want to, you know, bring that back or whatnot. So here you can see, yeah, we're getting this fluid going here. Pretty good. It's probably not going to work exactly the way I want it to, but it should work pretty well. So let's just say here we're going to do geo. Let's say let's call this render. I always say D instead of F when I'm typing. And it always comes out gold. All right, cool. stuff for our sims. So let's object merge those two things in. So we'll grab the, just scroll by out golf ball. Also get our fluid. Great. So we're going to say get geo. Perfect. So we've got our golf ball here, and we want to, let's just check out our P here. I'm not sure if this is what I used before. So this is kind of similar, except it does really weird stuff like that. So yeah, you can see that this will do a similar, like, moving it along the normal, but it's actually not liking it. In fact, what I probably should do, now that I'm thinking of this, is I should have more geometry here. So, because this is like a little sparse. So let's do that. Let's just put subdivide here. Calculate this, but that's okay. Do a subdivide as not that, but y. No, loop. There we go. Loop. I just want to have some more geometry in here. I might actually push it up to 2. That's kind of cool though. Just want to get some surface geometry in there so that it's, nope, still some more. Be good. I just want there to be geometry in here so that it's not, freaking itself out. And then, in fact, I'm going to just say only unchanged polygons will have, so that's actually what it's going to look like. And hopefully that will be a little bit of a nicer set of normals. In fact, I'm going to just calculate the normals one more time here. No reason not to, just make sure it's nice and, let's see here. Yeah, harden it up a little bit, maybe do it like 30. Oh, I'm actually just thinking of something that could be easier to do. We could do that same displacement problem, the same displacement thing we just did on this whole ball, where we just push it out with the normals, but I just want to have the normals actually incorrect to do that, which is fine. We can do that pretty easily. So also going to grab the collider as well. And I might, I wonder if I can do this. Ha! Sick. Totally worked. Love it. All right, so what I'm going to do here is I'm actually going to create a rest normal that I'll copy back over onto it. So I know that these are the normals that I want, but these will be the normals. I'll have other normals on there, so this will save it out. So I'm just going to resave this real quick. Boop. There we go. Out golf ball. That should all float together. Great. What I'm going to do as well is get, sorry, merge. Also going to get the collider one last time, because that is just a sphere, and that has normals, pretty basic normals on it, and that will help me do my move. So I'm going to get rid of this. We're going to attribute transfer. Let's shift these around. So golf ball, it's going to get attributes from collider. Only one I'm going to turn on is vertices, and I'm going to turn on N. Now, oh, that's so, it looks so bizarre. It looks smooth. Oh, that's so fun. So it looks basically smooth, even though there's, the normals are, even though there's all these points. So the thing that's going to be really interesting about this is I can actually displace this along this normal, and then after the fact, write the rest normal over top of this normal here and just copy it over. So, so now what we could do is I could actually come back to this golf ball, grab this same point pop here, and reuse it a little bit here. So let's do this. And so what I should be able to do here is displace it based on that. Let me just see what this looks like. It's kind of hard to see what's actually happening here. Ah, it's getting a little messy in there. Shoot. Oh, you know what? If I have attribute promote the normals to a point normal. Nope. So what I'm doing here is I'm just thinking that maybe we need to have this as a point normal instead of a vertex normal. You can always tell point normals because they're blue. They by default are blue. Yeah, that's working. So we have our point normals working, and it's pushing it out like that, and it keeps the shape, which is nice. But the cool thing is that we can now make this work to our advantage. So what I want to do is have it. I'm gonna have it fade based on an attribute. So just go inside of here, delete this amount, this little promoted thing there. That's gone now. Great. So what I'm going to do is I'm going to add an attribute here before this. We're going to do all of our work here. We're going to say displace. So let's do on integer. Just thinking of the easiest way to do this. I think the easiest way is going to be some vex. So y'all going to have to put up with some vex. All right. So what I'm going to do is I'm just going to have an attribute that goes from basically from 0 to 3.1 and have in the y direction. So I'm going to have this go in y. So let's just say let's set up a couple things. So we're going to want to do a start frame and an end frame. So let's do a let's see, start frame equals chi start. So this is going to give me start frame. This is end frame. Chi just means an integer channel, and we're going to do end frame. I'm losing you here. My apologies. But so anyways, so start frame, end frame. I'm just going to hit this little button over here. This creates these parameters for us, and we'll say the start frame will be, goodness gracious, what will it be? Maybe it'll start hardening at like 96, and then it'll end at 168. Let's just call it that. I don't know, 72. 72, 192. Let's do that. All right, so we'll do 72 and 192. Great, so we got a start and an end frame. Those are stored as integers. And then what we can do is all right, cool. Yeah, that'll work. So then we need to set an attribute. Just trying to think here. It's the easiest way of doing this. Sorry. Give me one moment. Un momento. So what I'm trying to think of is like the best way of doing this, and it's probably just super dumb. I should just do this really simply. Let's just do this in the simplest way possible. So instead of anything crazy like that and doing it with attributes, let's just do an attribute transfer and just call it a day. So what I'm going to do instead is I'm just going to do like just like a box, I guess. Let's just do this. Let's get out of here so I can. Great. Do divisions. Oops. Polygon divisions. This, I kind of want it to be like this, where there's like all these points inside, so that as it moves up, it's going to have, it's going to have room to do these things. So, all right, so let's just do it like that. That should be fine. Let me do an attribute. I'm just going to create an attribute. This effect. This will have a value of 1, so this means the effect is happening. Sorry, it seems like it's down on me again. Weird. Anyways, so there's our effect there, and then I'm also going to add this over here and change this value to 0. And the reason for that is when we do, oops, I hit a million things. Attribute transfer. When we do an attribute transfer to this from this, we want it to be able to basically blend those values. And this is point. Yeah, it's a float point. Great. So let's grab effect. That's all we need. And conditions here. I don't want it to be a distance threshold like that. Let's do like, I don't know, 5. Give it a couple samples. And maybe give it a little blend width. And let's go in here and see where the effect is. Cool. It's working. That's way easier. Don't worry, that's actually not going to 0. It's just, this is set to automatic. So if I come in here, right click on that, set this min and max to 0 and 1, and now you can see it's blue. And it'll just turn colors as I move it up. In fact, I don't want that to have the distance threshold that high. Let's just do it to like 0. It should just fade. Let's see. It's weird. Not sure why it goes red before it touches it, but that's fine. Whatever. Oh, because the blend width is probably so high. Great. Well, we can play around with that a little. Anyways, so this effect will kind of go across it like that, right? And what we can do is then put the second input into the first input, and all we're going to do is use a bind to bring in this parameter, which was effect. So we're bringing an effect into here, and we're going to stick that into a mount, and let's see what happens here. So if I do, well, first of all, if I just move this up, I should see something happening, but we're not. Oh, because I wasn't selected. And there we are. Boo boo. Oh, that's fun. That's just lovely. A little weird with these bumps that are going on there, but that's okay. That's very fun looking. Now, in fact, we want it to go the other way, so this should be at 1. It should be at 0, I want to say, yeah. Yeah. There we go. Got something going on. Cool. So there is our effect. Let's just animate this though first. So start this down here, there. To oh, weird. That is doing some strange stuff there. Okay. Yeah, we want that to be. The distance threshold was causing those ripples. Makes sense. I mean, I just. Probably too much at one. So what we can do here too is we can set the amount of displacement, the maximum value with this right here too, if we wanted to. Or also we could come in here and adjust the scale. The scale will cause it to, you know, you can change how much that is happening. And we could also, middle click here, promote that scale parameter, and then we have access to it up here. Just makes it a little easier to work with. Right. So, just trying to think here. The other thing we want to do possibly is, can you do this negative? Sure can. Okay, great. So we probably are going to want to actually cut that in a little bit even further. So we can actually go negative on that as well, which is cool. So let's take our fluid geometry here. Got that. And we can take this. Take the fluid geometry, we'll do a Boolean. Geometry A, geometry B. And let's just do an intersect here. And that should give us what we want, I think. Let's see. Ah, the one thing though, we need to replace our normals. Let's do that. So what we can do is we can, I'll do that down here. So let's do delete. I wonder if that's causing the Boolean to freak out. So let's do attribute delete here. We will move and then we can go into or actually here we can just say this basically just sets those two to the same. Should be the same now. And if we look at this, look at these normals now, they should look a little more the way they were. Yep, they're all kind of blend in there like they were. Great. Let's see if that'll Boolean or not. Oh, I know why it's not Boolean. Because this is probably a polygon soup. And sure enough, it is. Polygon soups don't like to Boolean because they're just all one polygon. So if we look at this, it's all polygon 0. Might be a little hard to see that, but it says 0 everywhere. And that's why I can't Boolean. So it was actually fine before, but we will fix that. So let's just do a convert here. And we're just going to change them to polygons. Now, there we go. We have 103,000 polygons instead of one poly soup. And if you are ever looking to change that, that is actually in the particle fluid surface under convert to. So I don't want to rerun that, so just converting it at that point, at this stage, is a little bit easier. Let's go back here. Now we should be able to Boolean. Sure enough, there it is. So this might not play super well. Got our fluid inside there. Yeah, let's just cache it, and then we can see what it looks like. So we'll do one more file cache here, and we'll call this just going to save this to disk in the background and let it start doing its thing. Then we should be able to play this down quite a bit easier, because we won't have to do the Boolean every single frame. Love some polygon caches. And you can see, obviously, it only will play up to the point of where we have it. So, where this is finished to. So, at the beginning, we won't see any of that surfacing going on the outside of it, right? Because it doesn't have the, if we look at this here, nope, wrong one, sorry. If we look at this here, it's outside of that size, basically. But then as we get up to frame, so right, like obviously that sphere is not going to be, they're not going to be intersecting each other at any point there. So it's just going to, or they're intersecting everywhere, basically. And then as this starts to animate in, which won't be till frame 72, so we'll get there in a second, we should start to see it taking those shapes. But looks like the CD is, or no, maybe that's just might be the. Huh? No, that is weird. The color is just not right at all. Could always attribute transfer that back, probably. But see, it's starting to move. Must have made the scale a little too big. Obviously, this is a really poorly meshed simulation. It's really low res, so this is not my finest. This is a better, smoother method versus going the VDB, VDB combine, convert back. Yeah, it's a great question. So is it a better option? I'm going to say that it isn't quote unquote better, but if you have a specific shape you need it to hit, this is going to hit that shape. Whereas with a VDB, you can only get as precise as your voxel size is, right? So like if you have edges that you want to be razor sharp. Now, you don't technically, there's no technical razor sharp edges in the world, but this will get you closer to your original geometry than a VDB would do. Now that isn't to say that that's not, that's completely the wrong way to go about it, but I think certainly there's something to be said about about, we could look at it basically. I don't think the quality would be there doing it that way, but it's certainly something to look at, So, but yeah, no, great question. That's a really good question. Looking a little weird. All right, so let's look at this here. It's doing its thing, it's shrinking in. There we go. We're gonna start seeing those things, those little dimples being written in, and that is really the difference here. I think is that this scenario, gosh, I don't know why that color is like that. It's so bizarre. I thought I would have kept. You know what? It's probably because it's taking the color from this. There isn't a color on it, so it's like confused. Um, yeah, and the thing with the VDB too is that like in order to get that fidelity back up, it's it's a lot of resources, right? So while this isn't particularly fast, I'm not using any like large amount of RAM or anything like that. But with a VDB, if you tried to get super precise with it, you could end up just absolutely just submarining your computer. So, it's something to think about with that. But um, I'll show you what it looks like and we can look at it for sure. I mean, there's no reason not to talk about it. Let me turn this off so we can get maybe a little bit better view of this. And I'm going to change the color to white. Again, I don't know, I think, well, anyways, I should have probably done the color transfer after now that I'm thinking of it, but it would be a very similar attribute transfer scenario where you'd get the color on it. Although I don't understand what's happening here now, so hold on a second. Why is that blue? What is making this blue? Oh, sorry. It is the right color. It was just my attribute. It was my attribute visualizer. It is the right color. Look at that. That's fun. Um, I was kind of a little surprised that it would be doing that, but oh, there you go. We get a little bit of both. Whoops. Anyways, yeah. Now you can really see where that. So yeah, with the Boolean, that is kind of the unfortunate thing. But we could obviously attribute transfer some of these colors back in and stuff like that. But kind of looks neat, I guess. Get a good sense of where it's going, and so if I play this back, I mean, it's gonna play back pretty much full speed. There's really no, I mean, it's going basically 20 frames a second. So as opposed to trying to view this boolean constantly, it's would not work. But that's basically what I did with my project years ago. I mean, I'm sure there's something different I did in there in some level, and obviously with a cleaner sim, you wouldn't have these random spots that are like sunken in like that, and the sim is whatever, it is what it is. But yeah, let's look at the VDB version of it. Now that actually might go faster if I'm thinking about it. But let's take a look. Okay, so really it's just from here that I would do it. So let's just do this here, and we'll do the polygons here. Go. Try just do it. 0, 1 is probably fine. And then let's grab this, the same thing. Yeah, I mean, you can already see, the difference here, the visual difference. But let's take a look here. So let me also do this. I'm going to copy this parameter. No problem. Thanks, Zach. Thank you so much for joining me. And yeah, if you're free next week, you can always join us then, and it'll be up online too if you don't get a chance to view it live. So yeah, thanks so much for hanging out. It was really great. Your questions were awesome, so thank you, and good luck with your stuff as well. Yeah, so VDB bind is this, and so if we do this, the trick here is you got to have it in the SDF intersection mode, and they don't really need to resample because they're in the same, whatever, they're in the same exact same sampling size. But let's see here. Let's here. Go back to a polygon. And yeah, I mean, it's not bad. You know what I mean? It's not a bad um, solution. It certainly is never going to be as clean. Um, you might want to add some adaptivity in there, maybe. I don't know, just a little bit, just to lower the point count. But let's see how. Yeah. So the interesting thing is that that is actually going on inside of. It's going on in this whole process is going on inside of the fluid mesher, right? So when you're meshing your particle fluid, it is actually using all these VDB nodes under the hood. I mean, it's literally exactly what it's doing. So, I mean, I'm sure there's a lot more calculations and stuff happening inside of there. But, I mean, this is probably a faster, but not as high fidelity solution. And if we do, let's just do this. Oh, no, I'm not going to do that. Is it hard? One little note as well with these is that these file caches under the advanced, under the save, there is a thing in here that says harden base name on save. And so when you save, it actually writes this name out as like a string. It gets rid of the dollar hip name, $ OS that it normally has in there. So if you copied this over, yes, it would need another attribute transfer to get the CD back. Although I think you could store the CD as a VDB uh, attribute. I don't know. It's a fog attribute, so it wouldn't combine properly. So what you would do is you would do this in two different columns, basically. You could do a surface attribute here with the CD. That'll create that. It's a color. Um, Oh, actually, you know what? The funny thing is, this would actually even almost work better because um, when you combine this here, we should have the color attribute like that, and then come back here to convert VB, and then oh, I was thinking there would be a transfer in here, but there's not. Yeah, you would need another transfer. I was thinking you could write the color out, but that only works if you're doing like smoke and volumes and things like that. Oh, excuse me. Oh, it's getting late. Anyways, let me just write this. But yeah, you're right. You would have to transfer it back. I just did a thing. Um, Somebody in a Discord chat or something was asking a question about if you could keep the identity of two objects that are being combined, doing this VDB combined like this. Could you keep them? And I kind of came up with this idea of putting like an ID attribute on both of them, putting that ID, a float attribute, putting that float attribute into a point thing like this, um, and then combining the surface VDB, combining that ID like fog VDB, and then merging them back together, and then what was it? I split them apart, visualize the tree. Yeah, that's what I did. So if you take this then and do, let's see from here, if you do a split, this can actually keep running because it already knows this whole tree, which is kind of cool. But anyways, if you do a split here and then VB tree, this is actually kind of neat. I just found this. So like you do this for visualize tree, and you do active voxels as points, and you do. Oh, right. they're both going to the right. That's fine. So we're going to do surface to the right. This is coming to the left. Hey, look at that. That's fun. So there's your points. So if you look here, these are the things that kind of matter. So active voxels you want to set to points. You can also do this wireframe boxes. I think that looks pretty cool too, actually, if I'm not mistaken. Oh, actually, you want to do solid boxes. That's like, it's really fun. Anyways, points, much faster. And you do points with values, and that does VDB, vector 3, right? 0, 1, 0, 1, 2. And then if you name the attributes after the VDB, it's now calling it CD0, 1, 2. Oh yeah, look at that. That does matter. So color. If you check that, it changes it to CDR, CDG, CDB. It knows either way. But then what we do is do an transfer here. And sure enough, this should actually... Oh, yeah, look at that. Worked. Yeah, look at that. That actually works. Actually works better. Um, yeah, isn't that visualized tree pretty cool? I think that's a really neat. I think that's a neat one. Just seeing it like that. The other thing, like, there's all these other things in here too that you can see, like the leaf nodes, um, which are the nodes that are actually being saved, if I'm not mistaken. Like those are the, yeah, it's crazy. This is just like, this node is like is like a masterclass on VDB alone, because like the whole beauty of VDB is that it saves data really efficiently versus trying to save every single voxel in the grid. It saves just like the leaf ones and stuff. But yeah, it's really fun. That's a fun one. And yeah, that worked really good actually. It put it right back on there. So you don't get the color from this one, but it's technically probably faster to play back. And then this one, you can get the color on it, but it's a little slower. Oh, you know why it's slower? Because there's a ton more points. That's why. Because here you're looking at 300,000 points, whereas this is 124. Just I don't think I could do a whole hour on that one node, but VDBs are really amazing. Honestly, I think VDBs are incredible. They're such a cool technology. Like just to give you a sense of how, like, so right now I'm setting up a lot of training on USD and Solaris, and in like for side effects. But I was just talking to somebody today about it, and I kind of forgot this, but literally in the USD world, they have like interpreters, like schemas for every single type of geometry that comes in. Whether it's a light or it's a whatever, it's a this or it's a that, it's a camera, it's this. So they have different ways of handling that data that comes in. But for volumes, they basically are just like, yeah, just give us a VDB because that's already good enough. Like, and VDB is awesome, but then you get into nano VDB, and that's a really interesting thing too, because that's what allows you to do volumes really efficiently on your GPU. So, anyways, VDBs, very cool. But yeah, you can do a lot with VDBs, I guess. So that actually worked a little better than I was thinking, and the attribute transfer part of it is really nice as well. Although, I mean, we literally could just use this same node over here and do this, and it's going to basically be the exact same thing, more or less. Now, granted, we've got all this VDB stuff that's coming through here, so we could just take this and put it in here, get the color. Yeah, pretty much. Yeah. So, I mean, it. There you go. There's two different ways of doing it, right? You've got attribute transfer here. You've got this. It's all similar. It's just what's your what's the flavor that you want it to be, and I mean this works, but you can see the kind of grossness of these. Like, it's not, you wouldn't want to render this, and granted, I wouldn't really want to render this either because this isn't great either. Like I'd want to do some stuff there to make that better geometry. But if you made like if in this example, if you made a golf ball that is render ready and has all the normal setup the way you want it to, and your materials and blah blah blah, all that stuff, and then you could just push it um, into this geometry that's already been this fluid geometry that's already been created, then you basically are just imprinting it with your render ready, all good normals, good topology, all that kind of stuff. And that was kind of what we did because we needed those golf balls in one shot to go from being a total mushy fluid to a hero, like this is the actual golf ball moment. And so it worked really well. And yeah, huge props to my buddy Zach for coming up with that technique, even though he didn't know Houdini. How did he say it like that? Man, I must be getting really tired. Even though he doesn't know Houdini at all, not at all, but not really. He was like, I think this would probably work. And he was spot on. So, anyways, why don't we call it there? I think we got a golf ball and got some fun stuff, and you got to see VDB visualized tree, which kind of rhymes a little bit. VDB visualized tree, everybody's new favorite node. Um, yeah. Oh, another thing too with this node. Now that I'm just thinking of it, points with index coordinates. This this is wild. It actually writes out the the index location of these points. So like point 244 is at negative 148, 108, 11. And I believe it's from I don't know if it's from the center of it or if it's from like one corner of it, but still it actually writes out the IDs of like what exact point, like what voxel, you know, it is, which is really fun. But yeah, if you ever want to do like pull the points out easily, that's a pretty good way to do it. Oh, I just do. Oh, I'm hitting stuff. What am I doing? Back. There we go. Anyways, sorry, I'm getting a little loopy. It's getting late. Well, thanks guys for joining me tonight. Thank you so much, Theo, I guess Theodore, for joining me and chatting quite a bit. And yeah, hopefully you guys learned something interesting here. And yeah, I'm always really just curious about ideas that people have for doing on this stream. This one was just something I was like, oh, I've never talked about this really. VDB goodness. All right, maybe we'll do some VDB next week. Maybe some volumes or, oh, you know what? Yeah, maybe we can do. I'll show a little thing about doing like an explosion that would be almost like from like an explosion, but it's like Legos. You know what I mean? Like how they do in the Lego movie where they do Lego explosions. I could do one of those. I actually set one of those up pretty quickly before, and it's easier than you might think on some levels. It's also a little complicated, but it's a cool little effect. So maybe we'll do something like that next week because that's always really cool. I mean, you can do that. You can also do you can pretty easily do fluid as well that turns into Legos with a process like this. I mean, obviously, as you can tell, you can just do like those boxes basically instead of doing it like this. You could just do the solid boxes, and then it starts to look pretty Lego-y. That's gotta run for a second, but this will look fairly Lego-y. But I mean, it's just boxes, So we could do some copy to points and things like that, and actually get some of the attributes coming around. But see, this actually won't even get the colors, so that's not as fun. So, anyways, yeah, maybe we'll do something like that next week. Maybe like an explosion or something with some BDBs. But anyways, thank you guys for joining me tonight on Houdini Hangout. Please reach out to me whenever. I'm on Twitter, pretty much. That's the easiest way to get a hold of me. Peter Kubik is my personal handle, and for the stream, it's just Houdini Hangout. And yeah, so thanks so much for joining me tonight, and I hope to see you next week. Thanks so much. See you guys soon.